Okay, so good morning and welcome to our TinyML Academic Network seminar, number 5, in fact. And my name is Marco Zanari, if we haven't met before, and from the International Centre for Theoretical Physics. Today, we'll have a fantastic speaker, Professor Marcelo Rovai from Brazil, which will guide us through in the setup of the Arduino TinyML Kit that I hope you will have in your hand and that has been received by your university. The way we will interact today is through Discord. So I hope you already joined our Discord channel. If you haven't, we posted the link in the chat, or you can find it here in the slides. So we will get your questions and your comments through Discord. That has the advantage that when you want to get back to the questions and answers, you can easily do it through Discord. So please use that channel for your questions. Just a few slides before giving the mic to Marcelo. So just a recap of what we did through this network last year. And we organized a number of seminars and we organized a one-week workshop. So we started in September. We had some introductory workshop seminars by PJ Reddy from Harvard, from Marcelo, from myself. And then we had this one-week workshop with different experts in October. So through that activities, we learned the basics of ML and of TinyML. And we are planning to work on applications of TinyML through 2022. So this is the new phase of our network. And in January, so just, last month, we received the devices finally. So you might know we have been waiting for these devices for long. And so we received them from Arduino, we shipped them to your universities, and now you finally have them. So today, we're going to have this seminar about setting up the devices by Marcelo. So what next? So we are planning 3 regional workshops. So one for Africa, one for Asia, and the other one for Latin America, starting at the end of April up to July. And the reason to have them regional is that then we can have more hours in the day. So you might remember in the October activity of ICTP, we only had 3 hours per day because of the time zone difference. In fact, we have our friends from Japan, it's really late in the evening. Our friends from Guatemala, it's early in the morning. So if we want to, have more hours per day to learn more about TinyML, we need to have these regional workshops. So I will send you the links to register for the workshops quite soon. In fact, the first one for Africa, I'm going to send the link, I guess, next week. So we said that we're going to focus on applications. That's going to happen in the first half of 2022. So what next? What about after these workshops? We're going to focus on deployments. So hopefully when you have learned about the basics of ML, TinyML, you learn about the applications, then you will be ready to deploy your devices and work on some cool applications. Something about the network. So you come from these 20 different organizations showed in the left. We have funding and we have devices to expand the network to 20 more universities. So that's going to happen in the next couple of weeks. And again, I will share the link to extend this network. So if you have colleagues from other universities that are working on TinyML or interested in working in TinyML, please invite them to apply so that this network will grow to 40 universities in total in a couple of weeks. Finally, another good news, we received the seed wheel terminal devices, and now they come in a kit, which is a seed wheel terminal TinyML kit. And so we will start shipping them next week. So you will get the Arduino kit and you also will get the wheel terminal kit. And so please let me know if there's any new shipping information or if you want to change something compared to the shipping information that you provided for the Arduino kit. And I think that is all from my side. So then again, please join Discord I will post the link once more. And if you have any questions for Marcelo, please use Discord to ask any questions. So Marcelo, the floor is yours.
Thanks a lot, Marco. Hello, good morning for everyone. I hope that we could enjoy today. I think everyone is very happy with the new kit, no? Okay, let's start here. I will share my screen. I hope everyone is seeing it. I leave the shot here, just in case. Okay, perfect. So the idea today is have an overview about the kit that you guys just received, and how it's work, how we set up the hardware, the software, all the libraries associated with the main sensors, not all of them, the few ones that's more focused in the applications, the most common applications that we will use in our next regional seminar. Okay, and but after that we leave some ideas how you can do more with the kits. We sent to you all the presentation. It's I'd say 95% of the presentation that I have today. I changed a little bit some slides only for clarification, so don't worry. The idea was because something you need to change, or during the presentation I need to put some more links, and together with the record of this session, we also will leave the new presentation, the PDF for the presentation for all of you. Okay, so do not worry if something is slightly different. Okay, perfect. So let's start here. Well, this is the kit. I think everyone have received this beautiful box. Correct. This is our kit. So our kit here, inside the kit, what we have here. This is the Arduino. Correct. The Arduino is here. Okay. This is the Arduino. We have here the camera. We have a cable to connect the Arduino to our PC. Okay, and this is all the support that we have to use everything here. Okay, so we're going details. Well, let's see. The most important part of the kit is the Arduino. Okay, so let's see. Let's talk a little bit about this little guy, the Arduino. First of all, it's important to know for you guys what's the Arduino. Arduino is the development board. Let's say what Arduino manufacture is a developing board. Inside the board there is a lot of device, the microcontroller, some communication stuff, sensors, etc. So some outputs, connection for output, so you can have send out data, collect data or signals, etc. So it's interesting. So it's a set of a lot of stuff that you need for when you develop embedded application. Okay, perfect. Some important things about this specific Arduino board, the Nano 33 BLE Sense. First of all, okay, here inside we have the microprocessor. The microprocessor is manufactured, the silicon is manufactured by Nordic. It's the name of the company. And inside we have the CPU. Okay, the CPU is ISO instructions developed by ARM. In this case, the ARM is a Cortex M4 with a floating point unit. What's very important for microprocessors, if you need to work with floating point variables. Okay, this board works with a 3.3 volts. In spite of the fact that you connect here USB with 5 volts, all pins here are connecting, receiving signal from outside and send signal to outside. Everything is 3.3 volts. This is very important because, for example, some of you guys that are used to work with Arduino Uno, for example, That's very common inside the universities for starting some hardware course. In the Arduino Uno, everything is 5 volts, for example. Okay, but here, if you connect anything outside with 5 volts, you damage the device. So 3.3 volts is mandatory here. Another important thing, we have the memory inside the microprocessor. Here inside the microprocessor unit, Nordic put some memory there. Okay, besides the CPU, we have the memory. We have two different memories. We have the flash, when usually you have the program or code is storage. So we have here is 1 megabyte of flash. It's very good, enough for the great majority of the applications that we use here. This, and the RAM memory is when we process when we run the program, that everything occurs inside the RAM. It's the same as in your desktop computer. Okay. And in this case, this device has only 256 kilobytes of RAM. And this is something that has a lot of limitation when we think about the model, the machine learning model that should run inside here. So you can imagine, so this size of memory should run all the variables of your code plus the model itself. So it's something to pay a lot of attention here. So power supply 3.3 volts and memory 256 kilobytes are the two very important features or characteristics of this microcontroller. This developed board Arduino has a lot of sensors. That's very good. That's because the name is sense. So they have a IMU, accelerometer, gyroscope, magnetometer. This is IMU, inertial unity. Have a sensor for color, for light, temperature, pressure, gestures. So a lot of sensors inside the board. Okay. One comment: if you read when you read the specification of the Arduino Nano, you also find the humidity sensor there. But in this specific kit that you guys received, the humidity sensor that usually in this part of the chip is not there. Okay, that because the shortage of the sensors or the components, electronic components all over the world, Arduino didn't find. That's one of the reasons for a long time delay. So we decide we don't need the humidity sensor inside. Mainly because usually for applications, when you use applications, for example, humidity, pressure, temperature, usually you go out of the sensor with a cable because usually if you go your processor usually is inside a box, or the temperature, including the heating from the CPU could change all the let's say the values captured for those specific sensors. So usually for real applications, we put this outside. In our case, as Marco commented with you guys, in a few weeks, all of you, all universities from our network will be receiving the seed kit, okay? And together with the seed kit, you also will receive a BME 280. It's a very good, very precise, very good sensors. So you have a pressure, temperature, and humidity sensors here. So with a cable, you can put outside of our kit. So don't worry. If you need some ideas or some projects that you need to use humidity for some reason, you can use this external growth sensor that you also receive. Or you can buy. It's very cheap. Digital humidity sensors. I think all universities has that, so you can also connect to the kit. Okay, so no problem about that. Okay, let's see a little bit more in details here. When you look at the board itself, let's see very quickly. This is something that I changed a little bit from the previous slides that I sent you during the week. I put in red here some main components that's more related to the system and to the communications. So for example, here in this part of the board, you have the processor, the microprocessor, okay, with the memory, flash, RAM, etc. The Bluetooth, the BLE is here, okay, so it's part of the, you can do wireless communication, okay. Here you have the connection with a USB. This is a serial connection, okay. You have, of course, you have here some integrated circuits that are responsible for this conversion, okay, from the USB for the serial to communicate here. We can say that we also have a button here. Usually the button is a sensor, is an input sensor, correct? But in this case, it's not allowed for you to use this button in projects. This button is connected to the system itself and has two main functions. One is reset. What means reset? When you press quickly once the button, your code inside go to let's say the line 0. So you start again your code. Usually you have one code that run continuously in a loop when is running in Arduino. We'll comment more about that. When you press a reset button, you force to go to the line 0. You go to all the setup phase and go again to the loop again. You start your programming again. Sometimes it's also important when you click twice, when you click the same button twice quickly, okay? So you come here, you click pop twice. You realize that this button, this LED, the yellow or orange LED that you have here, it starts to flash, let's say, like in a slow motion. This means that the board is waiting for a program. So it's good sometimes because, first of all, this board works with a 64 megahertz, so it's very quickly, very fast. So you can remember that when you have the board connected to your PC, all the time you are having serial connections, communications here. So sometimes when you try to send code, sometimes you got an error. So the best thing when you go download a new code to the Arduino, press twice this button, and the board stop the communication, let's say, to send information and start waiting for a boot. Start waiting for receiving the code from your PC or whatever. Okay, perfect. So we have some input sensors. Okay. Like, for example, we have the microphone, a digital microphone here, very good microphone, okay? And we have here the IMU that we comment. It's a 9-axis IMU, so accelerometer, three axes for accelerometer, 3 axes for gyroscope, and 3 axes for magnetometer. We have another sensor, another input here is the gesture, proximity, light, color, and light. Here is this one. We have here temperature and pressure. Okay, no humidity. Usually the humidity is also here in this, but here you have only temperature and pressure. So those are the main sensors that we have here. Okay, and also we have some way to do output. Okay. So when you do something with the board, sometimes it's interesting, not only send information. You can send information, it's very common, you send information or through the serial connection so you can see what's going on, or you can send information through your Bluetooth, or you'd like to see what's going on, let's say locally. If you try to do locally, you can for example, you can see RGB LED here. So, for example, depend of the circumstance when you do something. If this is, for example, if you are classifying image, for example, this is a dog or a cat. If you're a dog, you can flash. You can light the LED red. If it's a cat, you can turn on the LED blue. So it's good because you can only completely offline, only look in the device. You can see what's going on. Usually you have 3 LEDs here, the RGB LED, and you have here the built-in yellow or orange, depend LED in this part. So those are the outputs. And of course, you can also put a display or whatever connecting the device. We'll talk about that. Okay, perfect. So this is the main device of our kit, the brain of our kit. Okay, the Arduino 33 cents, the development board from Arduino. Okay, perfect. Second device or sensor, big sensor that we have here is the camera. So all this block here in the is the camera. Okay, it's some characteristics. Is a small camera. Is a very cheap camera, a low cost. It's a camera that works with 0.3 megapixels. Okay, it's QVGA. It's very common when you do image classification with such kind of a small device. Usually we will use 96 per 96 pixels or 48 per 48. Those are the most common, let's say, two size of the picture that you use. You can't afford to go more because you can imagine if you have a 200 for 200, so you have a lot of pixels to enter in your convolution network. So for use with a small Arduino Nano like this, make not sense have a big camera. So the size of the camera is okay. So the problem with this camera, this device is not the size of the camera, is how the camera is connected. This type of camera, he uses a parallel communication. So all the data, you have let's say digital communication with to control the camera. But when you capture an image, each line is sent in parallel in 8 bits per 8 bits. What means that the camera is slow. That's one problem that you have. So one characteristic of this specific camera is that you get 1 to 5 or 1 or 5 frames per second. So you can imagine, you capture a frame, you make the processing, so you go another one. So it's always you have only one classification per second. When with the devices like, for example, this is a Portenta, okay? This is a more professional, it's a TinyML device, but it's more powerful in terms of, the camera is also a tiny camera, but because this processing, you can have 30 or even 60 frames per second when you do inference, okay? So take this in consideration, but no problem, because the idea of the kit is more, in this case specific, with camera, I must tell you, is more for us to understand how to do it. But to be very honest with you guys, when you use image for real applications, I suggest that you can use other more powerful, or like powerful devices, like this Portenta, or even like a ESP32, that's no expensive, low cost, but in this case you can get more processing power for image classification, okay? So only for general consideration. Perfect. Let's talk about the shield, okay? The shield is the lower part, or the part that supports the Arduino board and the camera, okay? This is the good thing here was designed to connect both devices very easily, and I show you that's great, really great. Okay, we have here a button, a connection for external battery, and some growth connectors for output. We went in detail here. Let's go straight to see. Well, okay, first thing. So in this part, you connect your Arduino. Okay. Is the only, let's say, in terms of hardware assembly, we'll talk more after, but it's something that you must pay a lot of attention, because you can put in a reverse mode. So take care, okay? When you see here the button is more aligned with the output when you connect the USB, okay? So pay attention here. Here's the USB, okay? Remember, the other side you have the BLE and the microprocessor, okay? There is writing here, but here's the USB connector, okay? The USB connector. Fantastic. So you have here, in the shield, you have the microprocessor, and I put here on for you to have an idea. For example, I have here is the V-in, okay, the V-in, when you can also connect power to the Arduino. You can connect power through the USB here. It's most common when you connect the Arduino board to your computer using the USB cable. What's happened is your Arduino will receive 5 volts straight from the computer. Internally, he stepped down to 3.3 to go to power all inside the devices and sensors, etc., microprocessors, okay? But you also can use the V-in from outside. So including when you connect this battery here, what's going on is you are connecting here. So you can put here 26 from 4.5 to 16 volts, something like. So you can go straight here. So the internal conversion will reduce to 3.3, okay? You have here, for example, this Arduino board has seven analogic inputs. Internally, he has one ADC, it's analogic digital converter that was multiplexed to these inputs. The shield put available for you externally, okay, in this part here, 2 of them, A7 and A6. But if you want others, you can use outside. You put you took your let's say your device and used in a proto board. You can use all of the pins. In this case, it's only 2 available for you to know. What more? I have here is a I2C connection, it's a digital connection, very good for very quick. The great majority of the internal sensors are also connected with this communication protocol. Okay, you have 3 possibilities here to connect 3 I2C devices, and also let me see. And I have here you have a lot of digital inputs outputs. Okay, here. So the GPIOs here. 2 of them, the D11 and D12, is also available here. Here you have D12 and here you have D11. Okay, so take this in consideration. Not all the pins or the GPIOs or analog, let's say, outputs of the Arduino board is available in the shield. Okay, but of course you can use outside all of them. Okay, perfect. So the camera, I comment with you, the camera you connect here. So the great thing about this is you can see here is a lot of, you can realize here is a lot of cables that came from those 10 slots here and go straight to the several devices here. And I must tell you guys, this save a lot of trouble. For example, I made some projects before. Look, this is my first kit. I have a button here, I have the Arduino here, okay, I have a camera here, so I need to put all those connections here. So I can tell you that the great thing about when our friend Brian VJ from Harvard developed this kit for help us to quickly learn about TinyML, I can tell you this using here this shield was a very simple shield, but it is really helps a lot. Only for you to have an idea. Okay, fantastic. Again, as I told you, we have here the battery. Okay, you can connect from 4.5 to 21 volts. That in fact is this specification. This specification came from the V-in from Arduino, okay? And also we have this button here. This button is connected here to the D13. Okay, you can see here the connection here. Okay, so D13 here, and when you install the library for the shields, okay, automatically this button is connected there. I will comment there. Okay, perfect. So I connect here. I comment with you guys who have here the connections with I square C. I have the connections with some analogic and digital pins here. Okay, only for you to have an idea. When this was developed, Harvard decided to use the Grove. Grove is a seed connector developed by Seed Studio. Okay, Seed Studio developed. And it's very nice because it's very easy to connect an external device to here. So it's easy, it's clean, and for education, fantastic. So including in your university to do some jobs or to do classes. So it's good to have here. And as Marco commented at the beginning, you guys will receive with the next kit that you receive, the kit that runs. Let me zoom my hands here. With Seed, you receive two devices, two external sensors. You receive this one here. Okay, it's for sound measure. Okay, and it's connected to the GPIO, to digital pin, and we also receive the BME here 280. That's I2. So you can connect both if you want. Also, not only in the other kit, but also in this kit. And if you have, for example, if you have a LoRa LAN, for example, for LoRa, you can have communication. You can have LoRa device. You can connect and so on and so on. Okay, so there are a lot of possibilities here. Okay, perfect, super. I think this is finish our first part of our introduction in terms of the kit. Okay, I think that is important to give you all of you this general idea about what you're talking about. Before entering the next section, some big question, Marco, with people, or let's continue. Okay.
And continue. Yeah. If there's any questions, please use Discord.
Perfect. So, okay. So now, hands on. So let's start. First thing is very quickly is assemble the kit. I will not lose much time with this, but only remember, you guys, only please pay attention to the connection here. Okay, the USB will be lying here, circle the button here. Okay, the camera is okay. If you turn the camera upside down, you have a problem here. So connect both here, and the next thing, you should connect your USB here. Okay, so you connect the USB, and the USB is connected to the kit. Okay, so really, I think not a big deal. Next important thing, or the first thing in terms of software, for the main applications, if you are not familiar with Arduinos, etc., I really suggest to use the Arduino IDE. In my opinion, sincerely, it's one of the great things about Arduino. It's not only the hardware itself, but the Arduino IDE together with all the, let's say, the abstractions that was developed to reduce the complication when you program in C++. So it's Arduino did a really a good job here. Okay, so what should you do? Okay, you go to the Arduino page. If you Google Arduino IDE, boom, you go, probably you go straight to this page here. This is Arduino.ccen software. Okay, of course, one page for each one of your languages. Okay, the important thing here, for example, the last version is 1.8.19. So this is the versions that I'm using. It's okay, I tested. It's have a couple of weeks that was launched. And you should here choose the operational system of your computer. If you are Windows, you click here. If you have Linux, you choose your Linux version 32 or 64. And if you use Mac, as is my case, as Marco case that I know, you came here. It's worked perfectly in Mac Mac OS, running in the Intel chips, Intel CPUs, and also for the new M1 CPUs. Some work both. I didn't find any problem with that. So you select here. When you choose, okay, you download, you click and install. You'll be installed automatically. What's happened when, in my case, for example, I have here is installed. When I click, oops, I click. Okay, I clicked something wrong here. Sorry. So when I came here, usually when it starts, you see a blank IDE, let's say, when you start to make your program. Okay. Some important things. Here is the area. Okay, you can see here is the area where you enter your codes. In this central part here is where you enter your codes. Okay. So here is your code area. Okay. Perfect. Code area. What do you do? Usually here in the first part here you install your, for example, you come here, include library, blah, 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 blah. For example, you include your libraries that you need for your program. You came here something like, I don't know, define LED pin 11, suppose. You want your pin 11 be the pin that you use as your LED, and this will be the variable that you use inside your program. So usually, in this area, before this setup, you used to declare your variables, call your libraries, everything that will happens once or the beginning of your program. When you have all the libraries, etc., you come here to do the setup. What means the setup? For example, you say, this pin, this specific pin will be an output pin, because, for example, if you use a pin to turn on a LED, for example, is output. You receive it will be a button or a sensor that you are a digital sensor that's sending data, so it will be an input, something like. So you make all the definitions in this setup area. You define what's the bound rate for your serial communication when you make the communication with your computer, because it will be important for the beginning, and so on. Of course, this is only for the developing time. Usually when you are running your device, let's say doing inference, it's offline, you don't need any serial, okay? And the second part is the loop part. The important thing is setup run only once when you run the program, and the loop is continuously. This is the way that the concept of the program, the code you run inside the Arduino. You go once to the setup and continues forever doing the loop, unless you press reset button and you go again to the beginning. Remember that this is C++ and this is compiled. So when you write your program here, you can do two things here, or more than one thing. Here in the upper part, okay, in the upper part here is your menus and toolbar. Okay, you can, with this one, you make some verification. For example, probably if I verify here, we got an error. Oh no, he tried to save first, but of course you try. You look, it's an error here. Why? Of course, including library. He doesn't know what is this. I made a mistake, I don't want this. Okay, so if I put it again, I don't want to save. You go and he's trying to compile here. It's okay, I did nothing, only have made a definition here. Okay, when we run everything and see that everything is okay, I program without any problem. Okay, the code is okay. This zero code here is used. In fact, you use 43K because I have a lot of things inside. Blah 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 blah. So everything is okay, correct? You can came here and download. Okay, you can compile your code, or means you convert your C++ code, this language that you humans can see, can understand. You convert this to machine language, to ones and zeros that the Arduino will understand. And those compiled version of the code will be installed in the flash of the Arduino. Okay, so you do with this second button here, and you have a button here, new, and you have start a new area to make your code, a new code. Here, if you want to open one or save your code to your computer. Okay, and here you can see this is the terminal. Okay, this is a console. In fact, the console. When you get information, you saw when I make if I made if I made a mistake here, for example, I forgot to put a number here. Remember, if I try here, okay, and probably when he tested, we find an error. Oh, this case was not an error, but for example, let's put here something like here. Let me try here. For example, it's an error because I made a mistake. It's defined, not I forgot the n. Something like that here. Okay, perfect. So this is the Arduino he installed. But in theory, when you did the first time, I'm not connecting you to any device yet. This is only the environmental where you make your program. Next thing, the next step that we should do here is what? Is install the board or tell the Arduino IDE what board will be used. So for the IDE to know all the definitions about the pins, where's the LED inside, where every component, install some of the libraries will be automatically installed. Okay. For that, what we should do? You came here. We came to tools. Okay. At board. If it is the first time that you download, when you download the IDE, probably you see here you see Arduino Uno here. So we came here, board manager, click board manager, okay. We open the board manager here, okay. And what we should do? We came here, Nano 33 BLE. Okay. And he find here. Important comment. I have installed here in my machine. Look, the version 2.7.2. This was the latest version till I think yesterday. Yesterday, Arduino launched. Look, for me, appears a button here, update here, because there is a version 2.80 is a new one. I was with a group in some blog yesterday with the Edge Impulse, and some of the guys said that probably there is a bug in the camera connection with this new version. I didn't test yet. So, if you guys want to install the 2.8 and got some problem with the camera, you must come here, remove, and return it to the 2.7.2. Okay, so you can choose any version, previous version. So I advise you guys, at least for today, install the 2.7.2 that at least I tested. It's okay. I didn't make any confirmation that there is a problem with the camera, with the camera library. but okay, super. So you should install the Nano, let's say the version 2.7.2. Okay, I think everybody did it, I think, no? Okay. Let's see here, some message. Okay, what?
Marcelo,
Yeah.
should we ask people, are you all on the same page? So have you installed the Arduino IDE? And are you okay with installing the libraries? If you have any issues, let us know in the chat, please.
Yeah. Yeah, I can stop a few minutes here only for people to catch up and go to this point before to continues. So till now, we installed the IDE, and once you have the IDE installed, we went here to the boards manager. He turn here. You go to tools. Here. Why is something is running here? Let's see, let me do something here only to be sure. Wait here only to don't save. Let me put again. I don't have something wrong. So I'm open here the Arduino again. I open the Arduino. I came to tools, board here, boards manager. Okay, boards manager. Came here. Nano 33 BLE and install 2.7.2. Okay? Same page? Okay. Close here. Okay. At this time, okay, if you do everything, when you connect now, for example, when you connect your device and you come here to tools, you should see here, if you have more than one board here, for example, I have Arduino, I have the Portenta, so you need to come here and select your board. You see here, I select, you can have Arduino Nano RP2040 is the Arduino Nano with microprocessor. It's made by, is the Pico, made by Raspberry, so it's another version that you can have. But in our case, it's the Arduino Nano with the Nordic NPU, okay? So, perfect. So you come here, you select. When you select, you should come here. When you go to port, you should see, okay, this is your, for example, if you have a Windows, you have COM1 or COM2 or COM3, you have a COM port here. You should have Arduino Nano 33 sometimes appears, sometimes not. So maybe sometimes you see the COMs that you have without the Arduino, connect the board and see which one was appeared, so you can select that one. Okay, so this is important. So in my case, now I see that I have the board. The board here is Arduino and the port is connected to Arduino. So in my case, I'm happy. I'm connected to the Arduino. Okay, so seems that's okay. Okay, perfect. Okay. Everything okay, no? So next time, as I said, some of the libraries are still was automatically installed to the board when you installed the board Arduino 33, but some of them not. So, for example, for our test today, I would like to do some tests with with the IMU, with accelerometer, for example. And in this case, he's not there. So it's a case that you need to call for external library to tell the Arduino to use their IMU sensor. Is one case. Depend of the sensors. For example, if you use the BME 280, for example, you need to install the library to run the sensor. Okay. So this we install another library very to install the TensorFlow is the library that allows to run the is good because you have examples that some of you I know, for example, the word and book.
Well, I think we lost Marcelo. So let's see if he connects again in a second. In the meantime, we're lucky to have Jose in our group as well, and we see Marcelo again.
Yeah, sorry about that.
Yeah, it's okay.
Okay, I don't know. Sometimes I don't know. Maybe some things happen in my home here. So Marco, is okay my screen? Okay. So we stop here. I was talking to you guys that the next step we should install the libraries. Okay, we install the hardware, the Arduino itself. Now some of the libraries that were not installed automatically when you install hardware. For example, the library for the microphone is already there. You don't need to install another library. Okay, it's the library pdm.h is there. But for example, you need to we must install TensorFlow. Okay, I was talking with you guys that, for example, I suggest you to do some examples. For example, with the TinyML examples that are very explained in the Pete Warding book TinyML, and we showed at the end here. Another one important is the TinyMLX. It's a library that was developed by Brian in Harvard. Okay, and this library it's helping us with the camera. So in fact, the library that run the camera is there, and also some small codes, for example, to connect the button, to do the bouncing of the button, because when you press a button, usually you need to do a small to run a small code to do the bouncing. The bouncing is when you press one button, usually the button starts to do something like this to the time I press. You don't realize that, but in fact, the button do something to the end that the plates finish. And usually this goes 1 0 1 0 1 0 1 0. So you need to do a debouncing. What I do when I realize that a button was pressed, I wait a little bit to the time that the button is stabilized, so I can say, oh, now is 1, now is 0, now is 1, and not 1 0 1 0 1 0 to the time. So it's called debouncing. You don't need to worry about that, because this special piece of code is inside this TinyML library. So what you should do, and of course the library that I comment with you, the library of the IMU, is the LSM9D. So when you go here, returning here to our sketch, what do you do? Usually you should take care, because sometimes if you're not, for example, if you're not click here, I can see you not see the Arduino options there, correct? So the bar. So I click inside here. Now Arduino here, tools again, and now I go to manage libraries. Okay, manage libraries.
Marcelo, I don't think we're seeing now the right screen. at least not from my side.
Ah, really?
Yeah.
What? My goodness. What screen is showing? This one?
The Google Doc.
Okay. So I made a mistake. Okay, let me look here. So it should be desktop. Let's see, share again. So it's okay. Okay?
Not really.
No?
Mm-mm.
Well, because it's showing that we... Okay, let's see again. Strange.
Maybe you can stop sharing and start sharing again in a second.
Yeah. Because it's desktop 1. Appeared?
Nope.
Oh my God. It's telling me here that I'm presenting.
Oh, it's coming now. Wait a second. Okay, that's fine.
Okay. Yeah, I don't know. It's taking longer, no? Well, okay. I try maybe to stay in here. Okay. So let's I go again. So click over the IDE here. You can see here you have the labels here. You have the menu here. I go to tools. Okay, I go a little bit slowly maybe, and manage libraries. Manage libraries. Okay, manage libraries. So this is the library manager, and here you can select your libraries. For example, the first one is, for example, TensorFlow. So I can with TensorFlow. So look, when you type TensorFlow here, okay, in the search window, appears here. This is the Arduino TensorFlow Lite developed by Peter Warden. It's a 2.4.0 alpha. Okay, so you come here and you press install. Okay, in my case I have installed, but when you see the presentation, I left the screen that maybe I'm not moving because I don't know what's going on here if I move. Okay, so you can install there. Actually, wait a little seconds for people to install. Put to the chat. Okay. So enter, install. Second one that we should come here is the TinyML X, I think. Yes. So here, Harvard TinyMLX, no? By Brian Planter, version 1.1.1, 1.1.0 alpha. Okay? You should also install this version. This version, is like I said, will handle the shield, okay, some the bouncing of the button, and help with the camera, and also will install the OV767X. That's the library that will help us to run the camera. And that I told you guys that probably there is a problem with the library with the new IDE. I read this yesterday, but in our case, it will work. Okay? So install that. And the last one, at least for today, will be the LSM, no? LSM9D, the 9IX, I think S1 is here. So Arduino LSM9DS1, okay, the accelerometer, magnetometer, and gyro, okay, for the exactly what you have in Arduino Nano, blah, blah, blah. So again, version 1.1.0, you press install, okay. So let's say, look, you can also install the BLE. If you enter BLE, you can install BLE, but usually you don't use, at least we will not use today or in the next applications, but you can do that. And if you have other sensors, you can try to Google, you can Google, see what's the name of the sensor and what is the library. The procedure is exactly the same. You enter here, you look for the library, and the library will be installed in your Arduino IDE. Okay? Doubt so far? It's okay? So, at this point, I think that you have, let's say, everything ready, okay, for our start to testing our kit. Okay, we have the IDE installed, the hardware installed, the IDE knows our kit, we have all the libraries, the main libraries installed. The first thing that you do is now run some program to make some tests, okay? The first one that we should test, I think the most, the hello world for the embedded devices is the blink. Seems very simple, a simple application, and it's simple, but it's very powerful. When you run a blink application on an embedded device, what you are doing, you are testing if the device is running, the connections with the serial connections to receive the code, to run the code, and more, to connect to the output, okay, connect to the LED. This is something connected to the physical world. What we are doing here is connecting the software with the physical world. It's fantastic because we as a human can see the LED blinking, correct? So how you do that? When you have everything installed, if you come here to File, you can see here examples. In examples, every time that you install a library, you receive a lot of examples. For example, when you install the IDE, a lot of basic stuff appears here, okay? When you install your Arduino Nano, a lot of stuff appears here, okay? When you install the Harvard library, we have some tests available here. So each time that you install a library, usually those kind of examples come with you. It's very good because you can test your library. So the first thing, we install the Arduino. Let's test the Arduino without any library. And in this case, we come to basics here and we select blink. When you do that, look, the blink applications, the blink will appear here. And the blink is very simple, okay? We don't need to have any declaration before the setup. What will you do in setup? I only say, look, this is a LED built-in is a word protected or used by the system, in this case by the Arduino IDE, and they know automatically that the LED that you have inside the LED that you have here, let's see here, for example, you have the green LED that's only say that your device is powered, and you have the other LED, the built-in LED is a yellow or orange LED that is connected with the pin 13, okay, internally. So when you say LED built-in, automatically the system knows that you have the 13, you want the 13. You say, okay, I would like that the LED, this pin will be output, okay, only that. And during the loop phase, what I want right in that specific pin a value high. So I want that pin to go high. I need to delay 1000 milliseconds or delay 1 second, and again low. So it will be high, 1 second, low, 1 second, high, 1 second, low. So we start to blink the LED, 1 second, 1 second, 1 second, 1 second on, 1 second off, 1 second on, 1 second off. Okay, perfect. Let me close this. So again, how you can do? Let's test first. It's not necessary here, but it's a good practice before trying to connect with the device. Let's test. We can see here is the test, everything. Okay. So the program seems that the code seems that is okay. No error in the code. Next, what should do? We come in here and say upload. When I put upload, what we will do is we'll send that code straight to our device. Okay. So I came here. Okay. Upload. You can see here. He's starting to upload. Look, it's uploading here. It's flashing. Okay. You can see here. He said, the size that wrote here. And we can realize here that the pin is flashing. The yellow pin is flashing. 1 second, 1 second, correct? On, off, on, off, on, off. Okay? On that, I can tell you guys, it's very powerful. We just check a lot of things. Our ID is correct. We enter with a code. We make the connection between the computer with the board using the serial. We run that program inside our device, correct? And our device correctly associate one of the pins with the LED, and it's sending information to the physical world. So we accomplish a lot of things here. So this is the
Marcelo.
Yes,
Marcelo, there was one question about the reset button.
Okay.
So maybe you can explain about that. Do you need to press the reset button to upload the code, or how does that work?
No. It's a good practice. Press twice the button, twice, very quickly, not for blink, but for example, when you enter some sensor tests, because we are doing a lot of things inside, and make communication, send information out. Usually what I like to do, for example, I come here, I press the reset button. I press the reset button twice. When I do this, I'm not doing the reset. If I press only once, I'm doing reset. So if I press 1, you can see the board will start again and start back from 0. If I press twice, it's different. Now it's the same LED, but you see that it is like in slow motion. Means in this case, the program is not running anymore. I'm not in the loop, and the board is waiting to receive some code. For example, let's see. I went another code here, another simple code. I think it's good. Let me see. Open. For example, look. I enter here another program. A program that I wrote, very simple. So this is during the setup. What I'm doing now is I'm starting the internal RGB LED. Remember, we have the RGB it's up. It's in the up left part, just below the microcontroller. So during setup, I'm telling the LED R red, the LED G for green, and B for blue. Those 3 LEDs are outputs. I'm starting them with a high. Here is the opposite. Here is high is the way that the manufacturer creates this LED, this RGB LED. When you put high in the output, he's off, and when you put low, it's on. It's a way to, doesn't matter. It's only a command that you are send to them. So what I'm doing, I'm defining the 3 the outputs, the three outputs for this LED are outputs. I'm turning off, then putting high. And during the loop, what I'm doing, I'm right low in the red, turn off the red, turn on the green, turn off the green. So we're doing a blink in each one of these three. So let's try. Look, so what I did now, because I pressed twice, is the blink. It's very slow. You can do this or not. It's a good practice. Always do this when you do some charge. Mainly because usually when we are doing with TinyML, the code is a very intense code, and sometimes the problem is the processor is so busy that the system, they're not pay attention if you are trying to send another code for them. When you put that, you say stop doing anything and wait, because you receive a new program. Okay, perfect. So let's try this. So at least I will check if I made no mistakes. Okay, it's okay. Now I'm sending the code. I'm sending the code to the board. Okay, look, it's flashing there. You can see. Look, red, gray, no, blue. So the RGB is flashing. Okay. If I press reset once, nothing happened because he start again. But it's very quick, so you don't realize. Okay, the program continues. If I take out and this is important. For example, I disconnected. Okay, disconnected. When I connect again, if I connect again, the last program started, because it's the same thing. Disconnected or connected is the same as when you press reset once. So the program will start again. So remember, when you flash upload the code, or another word is when you flash the code is stored in the flash. The flash memory is a memory that this memory, when you cut the power, the content of this memory is not loose. The code continues there. Only the RAM you lose. Everything that are inside the RAM. If I save some codes or some variable value inside the RAM, when you disconnect, you lose that. Okay, but the flash, no. So it's connected, it's okay. So the program here. I will press again twice, very quickly. Now look, the program stopped. I'm not seeing the P again. Okay, but you can realize. I hope that you realize my camera, and you see the internal LED, the yellow LED is flashing very slowly. Okay, meaning that I'm waiting for some test, and this is good because I want now. I start to test some of our sensors. Okay. Doubt so far? It's okay. At the end of the presentation, I have this program available for you guys. Only I put again here. Okay. Next, let's start to test the sensors. Okay. The first sensor that we will test is let's say a microphone, for example. So how we can do that? I came here, file again. Okay. Examples. Okay. I came down to Harvard TinyML X, and I have here several examples. One of them is test microphone. I will test microphone. Okay. Let me the blink. Let me so not make confusion with you guys. So here is the program that was developed by our friends for Brian and his team in Harvard. Okay. Very simple. What you use here? Remember, I commented to you guys. The most important here is the library I'm not entering details in the program. It's not the case here. Okay, but only for you guys to know. Remember, before the setup, we are defining some things here, some parts. I'm defining, for example, the library. I'm calling a library PDM. It's an internal library that's runs the microphone. I'm including a library that runs the shield. Only I'm doing that because I use the button, and because I use the button in this particular code, I need to have this library, or otherwise the button will not work. Okay, perfect. And the next step, so I define a buffer. When I collect the information from this buffer will be used because the library, when I collect the sound that is coming from the microphone, you use this buffer to capture that information. But what do you do here? In fact, we will use the serial communication to show what we are capturing in the serial monitor and in the serial plotter. The IDE has two very nice tools. That's a serial monitor, where you can send informations. Your program can write there, or you can send during the runtime, when the program is running, you can send information to the board. And also a plotter, you can for continuous data, you can plot that. Until before this came, I think 1 year ago or 2 years ago top. Before that, you need to create a program external to capture all data and to use, for example, I don't know, or to plot your data, or go to Excel, whatever. Here you can see online how the signals are running in time. So it's help. It's only for test, but it helps a lot. So what do we do here? Okay, I'm not entering detail as I said, but let's run the program. Okay, so I'm compiling the program. Okay, so look, now I didn't press verify first. I went straight. I know that the program is working, so I went straight to the upload button. So he tested. It's okay. You can see here, test is okay, and now he's uploading. He start uploading here. Upload. Boom. Perfect. Seems that the code is working, but I don't see anything. Hello. Well, this program now, in this case, we should use the terminal. Some tools are important here. You go to tools here. You have serial monitor and serial plotter. Let's go to the monitor to see if something is here. Look. The program standards. Welcome to the microphone test for built-in microphone, blah, blah, blah. For test. Use the on-shield button or send the command click to start or stop the audio recording. Open the serial plotter to view the corresponding waveform. So,
Marcelo, I don't think we're seeing that.
Sorry, again?
Now it's coming. Now it's okay.
There is a delay, I think, no, Marco?
Yeah,
when I start something new.
Could be.
Yeah,
okay.
But you guys see when I open the terminal?
Yes, now it's fine.
Okay. So
can
you can use...
Sorry, Marcelo, can you just go through tools and then tools, what else there?
Yeah, you come in, look, let me, I close here. I'm here, tools, correct? Tools. And from tools, you have serial monitor and serial plotter. I first start with serial monitor, so I open, and it's open there. Okay, let me put a reset here. We should see, look, appears there. Okay. One thing important, for example, the monitor is open. I just open the monitor. If I try to open the plotter, I will receive an error, because this is very important. Sometimes you don't know what's going on. Is you have only one serial connection. My Arduino is connected to the computer using the serial, correct? What I'm trying to see here, how this welcome to microphone appears. In fact, this is here, look. When you see the program during the loop, during the setup, the program said serial print print with a line return. Welcome to microphone test. Use the those 3 lines that appears here. In fact, it was the program that sent once to there to there. Okay, if you because the program is running. If I close as I did before, it will be a blank because he only sent this information once. When I press reset, the information appears. Why? Because I return to the beginning again. I start the program again, and I could see these 3 lines there. So to do the test, I can right click here. So you can right click here and use send, or you can go straight to the plotter and use this button. The code do both. Well, let's start with click. I put send. Look, when I put send, I start to see the values that are connected. For example, hello. You realize that when I start to talk, the numbers, it's like an amplitude. It's bigger, but it's very difficult to see. So what we can do? This is the data that the Arduino is sent to the serial monitor. Only that. But what we can do is internally, I can close this guy. I close this guy. Close the serial monitor. Yeah, I can open a serial plotter. Okay. Hello. And now I don't have the serial monitor more to send the click, correct? So I can use the button physically. Look, I use the button, open the button again. Oh, it's a low frequency. It's my higher frequency. So you can use the button to start and stop. Only this, to capture the information or not. Okay. Okay. It's good. If you don't have the button, what you need to go to return to the monitor, send the click. Okay. Because of course it's our loop, the loop was did in this way. Okay. This is the test. My microphone is working. Perfect. Hello, hello. I'm a microphone. Hello, 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 hello. Doubt so far? Okay. All microphones are working? Someone had a problem or it's okay? Okay. Perfect. Now this is the case. Look, I'm very intense, very busy here. I have a Samuel. You say I have a problem? See if you are using the serial. Okay. For example, if I try to open the serial, yeah, sometimes you need to reset. For example, I'll try. I'm here. I'm trying I'll call this the serial monitor. Look, I got an error. Why I got an error? Because the plotter is working. So I need first, I close it here. If I try to open the monitor, now it's okay. I'm seeing the monitor there. Okay. Now I can, if I right click, is the equivalent to the button. I stop the value. It's the same. I put click again. Click again, send. When I do this, what I'm doing is I wrote click in my computer. When I put send, the value went here because the program is waiting for what's come and he analyzed, oh, if it's a click, I do this, okay? Perfect. So let's finish here. So he's very busy, correct? But now I do again. I do twice here to wait for boot. It's not really necessary. Sometimes works, sometimes not. So only for to be sure. So let's test the emu now. So I go to File, Examples, Harvard Tiny. I go more a little bit slower. Sometimes I think that there is a delay, you know. Test emu, okay? So Files, Example, Harvard TinyMLX, Test emu. So I open here, and the test of the emu will appear here. Okay? Okay? Same thing here. I'm including the emu library here. Okay? So this is the library that you have installed. Okay? We will install. And one thing important. Remember, this is what will appear in the serial monitor after. So when we press A, when A will call the code to run the accelerometer, G for display the gyro, in M to display the magnetometer. You can see here during the if you go down only for briefly, if you command, this is the command interpretation. When the board is waiting. If you receive an A, what's going on is, okay, you see that the index will be 0. If your G is 1, if your M is 2, and 0, 1, and 2 is the emu index here. 0 is accelerometer, 1 is gyro, and 2 is magnetometer. Okay? No, Meron is every time you run new code, you need to select the port again. Usually not. I made several, I changed, and usually I saw sometimes you got some instability. Probably a other program that you have running in your computer. Sometimes you can lose the port. So the good thing is disconnect your board and connect again, or select if you lose that. But usually not. Okay? Like, for example, I just finished the test with the microphone, and now if I look, my port is still there. But happens with me happens sometimes. We lose the connection with the port, so you need or select manually again or disconnect it, connect it to appear, because sometimes the port disappears. Remember again, there is you have a lot of things in your computer using the USBs, so it's complicated sometimes. Okay, it's a problem not with the board or kit, but it's your operational system. Okay, perfect. Okay, so let's upload. I'm upload the emu test. Let me see if there's some question. Okay, the code is okay. It's flashing. Perfect. Now it's flash. Let's take a look here. Serial monitor. Now I must open the terminal first, because I need to tell the code, because in fact it's only the way that the code was. We could do 3 different codes, but in this case, or I'll use the button, for example. I don't know, press twice this button, make some kind of code here. But it's your choice. But in this case, we need to, for example, I want to test the accelerometer. What I will do, I enter with A here, A, and send. Okay? That you can see that the accelerometer will work. Let's see. I'm up. It's difficult. Let's see. It's difficult. But because it's running, I can close the monitor and open the plotter. I think it's better. Yeah. Look. So here, let's see. If I go vertical, the green Z, look, this is the Z axis. You can see the Z axis. So stop again. Let me see this one. I go in this direction. Is the red. So this is the YX. Okay, Y. Okay? And the third one should be the X. It's go here and here. So it's the blue one. The blue, you can see here. Blue is X. So I'm going this direction. Okay? So look, it's axial. So if you go axial to the Arduino, it's X. If you go in this way here, okay, it's Y. And this is Z. It's working. Correct? Perfect. The program, you can see here, there is some, the program does some escalation. You can see here that the green line, for example, I'm not moving here, but one of the X is showing a value. What X is that? Is the Z. Why Z is a value? Has a value. It's 9.8 meters per second. It's the acceleration of the gravity acceleration. Of course, it's because I have escalation there. So this is 1. Okay, it's 1G. This is the scale here is G. So it's 1G. You can see here I have 3G, 2G, 1G. So the XZ has 1G. Now I have more or less 2Gs in a Y, for example. Okay? So my accelerometer is okay. How about yours? Working? Guys, accelerometer okay? Perfect. So, next one. Let's test the gyro. Serial monitor. Let's try the gyro. G. Wait a little bit. Seems okay. Let's see with the graphics. It's easier. Serial plotter. It's more like look, for example, I'm doing that. I'm in X. This is row, correct? This is row. I can have this. Look, is the green one, okay? Yaw, no? And pitch here. So you'll have a row, pitch, and yaw, correct? Row, pitch, and yaw, okay? Row, pitch, no? And yaw. So it's okay, it's working. Putting it here, let me see. Over the table. Perfect. So gyroscope is good when you have some movement. For example, here, let's say. For example, here, correct? When you have a rocket, for example, you can have here is the roll, correct? You can see this movement or this movement, correct? So you have this, and this, correct? So they are the three coordinates that you can have here, okay? Samuel, what the process you mean again? Okay, what I did when I changed the test, okay? So I came here, I came to serial monitor, okay? First, I test the accelerometer, so I sent A. So now I test the gyroscope, I sent G, okay? So I sent G, okay? So to be very to confirm, I went to the plotter, okay? So I can see here, I stop here, I have a row here, okay? I have this movement, okay? Look the green, and I have this one, the red one, okay? So blue, you row, so this is row, correct? This is row, this is another movement.
I think we lost Marcelo again. Okay, Samo, you say the code is working, but cannot see the graphs. You cannot see the plot.
Yeah, I can see the plots. And
Yes.
I've gone to the serial monitor. It came out well displayed the first time, but when I sent in the letters, I did not see any graph.
Have you clicked on send after entering the letters?
Yes,
So
I did.
Oh, but it's two different tools, right? So you don't need the serial monitor. You need to close that. You need to open the serial plotter.
Yeah, I did that too.
Okay, try to close it again and launch the serial plotter once more.
It's all right. It's okay. Thank you.
Sorry, guys. Are you seeing me again?
Yeah. We can see you. Yeah.
Maybe Mark, I probably with the Zoom itself. I think the problem is with Zoom, but
Could
okay.
be. Could be.
Yeah. So the 30, so the gyro, okay, is working. So the third one is so the third test will be, let's close the plotter again. Always, we need close. Monitor. Okay. It's the direction. So if you change direction,
Axel, I'm afraid we cannot hear you nor see your screen. Do you want to try to stop your video? So let's see if the connection is better if you don't transmit your video. Okay, let's see if he can connect again. Marcelo, do you want to try to switch your video off and let's see if that works better if you only have audio and slides?
That's not a problem. I think the Zoom is the problem, but okay, let me see how I can do that. Stop the video. Okay. Okay. So what we did now, I enter here with M. Okay, I'm in the serial monitor here. Okay, I enter M and send. So it starts the set again here. And send, and I got here the magnetometer. let's close. I'm closing close the monitor and open the plotter. Okay, so I can see the plotter here. The magnetometer, there's no camera now, but it's it's related with position. Okay, so if you change the position, now, for example, in the other case, zero, for example, if you put in your table, everything became zero. But here, if you change the position, you move in certain angle. If you change the angle in your table, you see that the values will change. Okay, the same with the 3x. So magnetometer is related with the position of the IMU related to the Earth. Okay, usually you need to, if you need a real very good position, correct position, you need to do some setup before, etc. But doing movements, put in your table and move and left you in certain angles, you see that you can read some different values. That means different angles of the position of the board over the table. It's clear? It's okay? Okay. So that's it. So guys, now we have the so the three sensors. The image is only one, but in fact we have three different sensors here. And now let's test the camera. It's a little bit more, but let's see that let's
Marcelo, I'm again afraid that we cannot hear you.
no.
The audio is completely broken.
My God.
Yeah, well, that things happen, right? Yeah, there's as we know, there's many variables, and connectivity is one, zooming is the other. So again, these things happen. Don't worry. And I think that the good point is that you provided the slides, right, with all this documentation, and I think we're like 90% done, right? So people learn how to install the IDE, how to get started with the board, how to assemble the board, how to go through the basic examples. And so maybe my suggestion would be to leave it as an exercise to go through the video example and let us know in Discord if you have any issues or if you have been successful. So if you have been successful in getting the video and going through the video example that Marcelo shared, then please let us know in Discord and you will get some extra points.
Okay.
Okay.
Okay, guys. I took a lot longer than we have
No, it's fine. It's fine. I think, as usual, getting started is the hardest thing. But then when you have the tools and you know what is the process, then you can go through all the examples.
The process with the camera is more or less the same. You start the test. The only difference is that when you capture the camera, you don't see for the test, you are not seeing what you are capturing. So you need to copy the hexadecimal value from the terminal, and you should use external codes. In this case, I left for you guys the collab that the guys from Harvard did that converts the hexadecimal to an image. But don't worry so much because the camera test. It's not a good test because it's not easy. When you connect our kit with the edge impulse, for example, it will be easier. We can connect the kit with the edge impulse. The edge impulse will show you what your camera is capturing. So in fact, this is the way that we will procedure. Probably we'll do this during the seminar, or we can do something before that to do some work, okay? Or you can do in parallel.
Okay, super. So please let us know if you have any issues with the camera and how that works in Discord. We're, always there, and you can ask for help, and we will be happy to assist. So I think on behalf of, all the participants, thank you very much, Marcelo. That was extremely nice and useful. And again, if you need any help, you have access to the PDFs, and you have access to us in real time in the chat.
Okay. Remember
Okay.
again, I will send you a updated PDF. Okay, Marco, and we put there, and I'm
Okay.
available.
Super. Excellent.